Thanks for joining me in today's lesson. In this first tutorial, we will state all possible rational roots for a polynomial. We are looking at section 5.6 and we're talking about our rational roots theorem. The rational root theorem says that if we have a polynomial f of x, and here's our standard form, that has integer coefficients, then every rational zero of our function must be of the following form. We're going to take our constant term and we're going to call that p. We're going to take our leading coefficient and we're going to call that q. And if this function has a rational answer, then it must be of this form. We're going to take the factors of p, that's the factors of our constant, and we're going to divide them by the factors of q. And that is the factors of our leading coefficient. This will give us all of our possible rational answers. Let's remind ourselves what a rational answer is. A rational number is a ratio. It is a fraction. So if there is a fraction that is an answer to a polynomial, then it must be of this form. And it's pretty simple to do. Let's look at our first direction. It says list all of the possible rational zeros for our function using our theorem. So here is our first function. I'm interested in the constant. I'm going to call that p. That's 12. And I'm interested in my leading coefficient, which I don't actually see, but I know that it's there. It's a 1. So I'm going to call that q. To find all of our possible rational zeros, I do all of the p's divided by all of the q's, all of our factors. Let me do my division bar, make it long. All of the factors of 12, and let's go in order. I know 1 goes into 12, but I'm going to say plus or minus 1. We always have to do plus or minus because we could have negative rational answers. 1 goes in, obviously. 2 goes in, so plus or minus 2. 3 goes into 12, so plus or minus 3. 4 goes into 12, so plus or minus 4. 5 does not go in, but 6 does, plus or minus 6. 7 doesn't, 8, 9, 10, 11, those numbers do not go into 12, but 12 does, plus or minus 12. I didn't make it long enough, there we go. These are all of the factors of our constant. These are all of the factors of p. And luckily, we're only dividing by the factors of 1, which are simply plus or minus 1. So we take all 12 of these numbers, remember there are 6 positives and 6 negatives, so all 12 of these factors, and we're dividing basically by 1. So it's really not going to change anything. So all of our possible rational roots, I'll put a colon here, are basically everything that's in the numerator. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are all of our possible rational answers. Now, there are not 12 answers to this cubic. In fact, there will only ever be 3 answers to a cubic. But if there are going to be rational answers, the 3 answers have to be one of these 12 numbers. And we'll look at a future tutorial, actually the next tutorial, how to find which ones actually are the answers. These are just the possible ones, which is kind of interesting because, you know, before this rational root theorem, there, I guess, would be infinite possible answers. At least now we're narrowed down to 12. Instead of infinite numbers, we only have 12 to choose from. And that is pretty powerful. Let's look at our next one. A little bit trickier. So I'm looking at my constant term, and I really don't care if it's a positive 10 or a negative 10. I'm just going to call that p, and my leading coefficient I do see this time is a q. So I'm going to take all of my p factors divided by all of my q factors, and let's draw my division. Let's talk about 10. Obviously 1 goes into everything, so plus or minus 1. 2 goes into every even number, so plus or minus 2. 3 does not go in, 4 does not go in, but 5 does, so plus or minus 5. 6, 7, 8, 9, no good, but obviously plus or minus 10 would go into 10. So those are the 8 possible factors for p. Unfortunately, we have a bigger number than 1 for our q over here. Plus or minus 1 goes into 4, plus or minus 2 goes into 4, and plus or minus 4. When you have multiple parts of your denominator, it makes it a little bit trickier. Let's list them here. Possible rational roots. And let's try to go in some sort of an order. I'm going to take all 8 of these factors and divide them by plus or minus 1. And when I do that, nothing actually changes. I'll go ahead and draw a circle around this division that I'm doing first. Nothing actually changes, so it's really just the same numbers as are in the numerator, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. I'm going to change colors. What I need to do next is take all 8 of these factors and now divide them by the 2. So I'm going to draw a circle around that. Now I'm dividing by the 2. If you have a different color, maybe that would make more sense. So plus or minus 1 divided by plus or minus 2 becomes plus or minus 1/2. Plus or minus 2 divided by plus or minus 2, well, 2 over 2 just reduces to 1, and I already have that plus or minus 1. So there's no need to put it again. Plus or minus 5 divided by plus or minus 2 gives us another one, plus or minus 5/2. And plus or minus 10 divided by plus or minus 2, well, we've already done that because 10 divided by 2 is 5, and we already have that. So no need to do that. And finally, our last one, we have to take all 8 of these factors and now divide them by 4. So I'm going to take and circle all 8 of these, and this time divide by 4. Hopefully this isn't getting confusing. It's a good thing I've got colors. So plus or minus 1 divided by plus or minus 4, that gives us 1/4. We haven't had one of those yet. Plus or minus 2 divided by plus or minus 4, 2/4. Well, that just reduces to 1/2, and we already had that. So again, no reason to put that again. Plus or minus 5 divided by plus or minus 4. We haven't had plus or minus 5/4 yet, so there it is. And lastly, plus or minus 10 divided by plus or minus 4. 10/4 reduces to 5/2, and we've already done that. So here are all of our possible rational roots. And that's really as tricky as it can get. You just go in some sort of an order and make sure you have all of them. Now, how many is this? 1, 2, 3, 4, 5, 6, 7, 8 positives, and therefore 8 negatives. 16 possible rational roots. And that's how you find the possible rational roots for a polynomial function. Thanks for watching this, and we'll use this skill in our next tutorial. See you in class. Bye-bye.